and biconditional statements. All right, so these first few problems here, problems 14 through 19, give us a picture here. So I'm going to draw it so that we have it for reference as we do these. When you're doing your homework problems, you can just draw the picture once and use it to refer to. You don't have to draw it every single time. All right, so that's what your picture should look like. Okay, so just a couple things to note: the lowercase letters that are often in your book written in it kind of looks like almost like italics. Those are your names of your lines. Okay, then your points on the lines are listed obviously as capital letters. When they have the little red box here, they're not going to draw it on all four of the angles. As long as one of them is there, you know that they have to be perpendicular, right? They all are going to be right angles. So you can just assume then that all of them are going to have that box.
Is that like an N by the...
Right here? Yeah. Trying to make it like a curvy, like little N, but it kind of looks a little funny. Has a tail on it. Yeah. And typically, you're also going to notice when they draw like a picture like this, they're not going to use the same letters for lines as they are for points, even if they're using lowercase and uppercase, just so that it's not confusing. This one looks a little, there we go. Well, looks a little better. All right, so 14. This says to use the diagram to determine whether the statement is true or false. Angle DCJ and angle DCH are supplementary. What does it mean for angles to be supplementary? 180 degrees. So, DC... Where's J? Oh, thank you. J is somewhere over here. I was like, where did it go? DCJ is over here. Okay, it's this angle right here. And then DCH is right here. So are these two angles supplementary? Yes. Yes, they are. So this is true. Segment FB is perpendicular to line N. So that's this right here. Is this perpendicular to line N?
Yes.
Yes, so this is true. Can't go too far away from my picture. Line M bisects angle JCH. What kind of angle is JCH?
Alright.
No.
That's a line 180 degrees.
So that's called,
Supplementary.
Straight.
it's a straight angle. Supplementary would have to be a pair of angles. So this is a straight angle. Now, my picture is not the best. But does line M bisect that? Yes. If you look at the book, it actually looks a little bit more like it. But yes, it is true. my J a little bit. Well, I actually put my H too close. So obviously you're using the book when you do that, so it'll be more obvious that it is, but. All right, next thing. Rewrite the biconditional statement as a conditional statement and its converse. So 20 is two angles are congruent. And again, if you want to write the number 2 instead of like the word, you can do that. So two angles are congruent if and only if they have the same measure. Now, another way that we can write if and only if to shorten it as like a shorthand is we can write IFF, okay, which means if and only if, so it's just like an abbreviated way to not have to write the whole thing out. As a symbol, because this wasn't in the PowerPoint, if and only if would have, it's basically like 2 lines and then an arrow pointing each direction. Because a conditional statement would have like one with it pointing like the other way. It'd be like 1 line with the arrow. So this one shows you that it works both directions. So either way, a lot of times you'll see me write if and only if is IFF. So just be aware of that. All right, so my conditional statement any idea how I would write this? Is an if then?
If 2 angles are congruent, then they have the same measure.
Yep. If 2 angles are congruent, then they have the same measure. Somebody else tell me what the converse would be.
Two angles have the same measure, but they are congruent.
Yep. If 2 angles have the same measure, then they are congruent. Now, it's not asking us this, but is that true both directions?
Yes.
Yes, that would be. All right. Give a counterexample that demonstrates that the converse of the statement is false. So they've already given us an if-then statement, and they want us to basically give a counterexample showing that it's false. So 24, if an angle measures 94 degrees, then it is obtuse. Now, is that true? Yes. What would the converse of this be?
If it is obtuse, if it is obtuse, but it measures 94 degrees.
Yeah. If an angle is obtuse, then it measures 94 degrees. Now, is that true?
Are you asking if it's
Technically,
could be
yes,
true?
False. Okay? It's not always true. It is true in one situation, but obtuse angles have what values?
91 and 179 degrees.
Yeah. So, I could say as a counterexample, (100 degrees is obtuse, but it is not 94 degrees. All right, because 100 degrees can't be 94 degrees. All right. The next ones give us a picture here. So they have a square, and it's PQRS is our square. Determine whether the biconditional statement about the diagram is true or false. If it's false, provide a counterexample. So 28. Segment SR is perpendicular, so I'm just drawing the little perpendicular symbol, to segment QR if and only if angle SRQ measures 90 degrees. Yep, that is true.
Rewrite true.
F has two F's.
Somebody want to explain it since I've already said it, what it is? If and only if. Angle PQR and angle QRS are supplementary if and only if the measure of angle PQR is equal to the measure of angle QRS. It's not going to fit. Is equal to 90 degrees.
Yes, true.
You sure?
No. I think.
Is it possible that it's true?
Yes.
But is there a chance that it's not? Or is there a way that it could not be true?
Travis witness.
Okay, yeah. It still has four sides, right?
Yeah.
They didn't tell us that all these sides are congruent. We're making an assumption. And we're assuming that these angles are 90 degrees, but none of them are shown to be 90.
Yeah.
Okay? So while this could be true, it's not always true, necessarily. So
Could be a trapezoid or.
we would
what's
say
the other shape?
false. Angle PQR and angle QRS could be supplementary if angle or the measure of angle PQR is, say, I don't know, 85 degrees, and the measure of angle QRS is equal to 95 degrees, because that would still add up to 180, right?
What number plus what number?
85 and 95.
Yeah.
Yeah. And they look 90 degrees, but what if I didn't draw my picture quite right? Right? They're not specified to be 90, so they could be something close that still looks like it, but is slightly off.
I agree with that one.
Okay. 34. These ones say to rewrite the true statement in if-then form. So we're writing the hypothesis or the conditional statement first. Then write the converse. If the converse is true, combine it to make an if and only if statement. If it's false, provide a counterexample. So there's three things that I'm going to be writing on these problems. So 34. The perimeter of a triangle, and again, if you want to draw a little triangle symbol instead of writing out the word triangle, you're welcome to do that, is the sum of the lengths of its sides. So my conditional statement, my if-then statement could be something, it doesn't have to be exactly this, but something along the lines of, if a number is the perimeter of a triangle, then it is the sum of the lengths of its sides. What would my converse be if this is my conditional?
If you add the lengths of the sides, it is the perimeter of the triangle.
Yeah, that's fine. So if it is the sum of the lengths of its sides, or I should say if a number. Then it is the perimeter of a triangle. Now, as that statement sits, is that accurate?
Yes.
No.
Not necessarily. So I probably should make my if part of my statement a little bit more specific.
All of the three sides.
Yeah, so I should probably say if a number is the sum of the lengths of either say of the triangle sides or the sum of the lengths of the three sides, something like that, then it's the perimeter of a triangle, something that makes it more specific, because this is a true statement, but we can have other shapes too. So we should probably specify, even though it's not necessarily specified up here, it would still make it a true statement. So I should probably fix this to say if a number is the sum of the lengths of three sides or something like that, then it is the perimeter of a triangle. Or I could say if a number is the sum of the lengths of the sides of a triangle, then the number is its perimeter or something like that. Something just to make it a little bit more specific. So now, is this true with what I've written?
Yes.
Yes. So I can write it as a biconditional statement now. So this is true. So biconditional would be something like a number is the perimeter of a triangle if and only if it is the sum of the lengths of the triangle sides. Or I could say of the three sides or something like that. But something to specify that it's for the triangle to make sure that it's true. All right, our last problems are actually using algebra. So they're going to give us basically an equation and then a value, and they want us to basically say if the statement can be combined with its converse and still be a true statement. Okay? So 38, if 3u plus 2 is equal to u plus 12, then u is equal to 5. So if I have a problem like this, I would probably solve it out first and solve for u and see, first of all, is that even accurate before I go any farther with it. Huh? So if I subtract the u from over here, then I get 2u, subtract the 2 from over here is equal to 10. Divide by 2, u is equal to 5. Okay, so I at least know that my initial statement is true. Okay. Now, what would the converse of this statement be?
If
If u equals 5, then for u plus 2 equals u plus 12.
Yep, so is that true?
yes,
Yes, so we've shown, like, that's part of what we've shown is that the value is true. They want us to write it as a biconditional statement. So all we need to do is basically take out the if from the beginning and replace then with if and only if. So my biconditional would be 3u plus 2 equals u plus 12 if and only if u is equal to 5. This is the biconditional statement that we're trying to find. If the converse is true, which the converse was true.
What's the box around the U for?
It just keeps, it's the mode that my thing is in. All right, 40. I was going to do 42, but it's just like the one we did in the PowerPoint, so I'm going to do a different one. 40. If w squared minus 10 equals w plus 2, then w is equal to 4. So I could plug in 4 and see if this is true. If I plug in 4, I get 16 minus 10, which is 6, is equal to 4 plus 2, right? But when there's a squared function, oftentimes there are 2 answers. So I'm going to try to solve this and see what I get, okay? Because there might be another answer option besides just 4. So I'm going to move this stuff over to the left. So I've got w squared minus w minus 12 equals 0. How would I go about solving this equation?
Didn't you like combine the W's?
I cannot because one's squared and one's just regular.
You can add 12 to 0.
I literally just moved it over. So word starts with an F.
move W over.
That doesn't start with an F. Has 5 letters. Second letter's an A. C.
Saw it? No, that's 6.
Actually, it does have 6 letters, not 5 letters. Factor, yes! So, I need factors of negative 12 that add up to negative 1. What would that be?
4 minus 3.
4 and negative 3. Or negative 4 and positive 3, technically. Because we need a negative 1 value. So, this means this factors into w minus 4 and w plus 3. We set each piece equal to 0 and solve, so w minus 4 equals 0, w plus 3 equals 0. So w equals 4, or w equals negative 3. So is 4 the only option that works here?
No. 3.
No. So while this is true, that this is one of the options, it's not the only option. And so we would say something like, no. Basically, the statement is not true if w squared minus 10 equals w plus 2, then W equals 4, or W equals -3. Okay, so those are our two options. So we're kind of like rewriting this statement as the counterexample for it. All right. Questions? All right. Problems then are 13 through 21 odd, 25, 29, 31,
I thought we already did 30.
33. This is a new section.
Oh, yeah.
And then 39 and 41. These are due tomorrow, but you've got 15 minutes. You should be able to knock a lot of this out. I know it's a lot of writing, but you still should have plenty of time. Make sure you write the statement that is the question. Okay, not the instructions. You're writing the question, just like I do. We're in chapter 2. This shouldn't still be hard, but it is, apparently. Yes.